The Anand Group. As India's leading auto component manufacturer, we power just about every type of motor vehicle. Cars, commercial vehicles, off-highway vehicles, two-wheelers, and even trains that run in India.
There is an ever-growing demand for stringent quality norms from our key customers. The customer expectation, along with strong competitive environment, has brought in the need to attain and sustain world-class quality levels.
Mr. Deepsi Anand, the founder of Anand, firmly believed in the ethos that in order to be the best, you have to work with the best. The group's journey of partnerships began with Gabriel in 1961. Over the past 6 decades, Anand companies have successfully integrated the technical expertise of its joint venture partners into local operations, creating win-wins for both our customers and our companies. Today, the Anand name is synonymous with trust, innovation, and quality.
With its wide range of solutions for the Indian automotive market, Anand companies provide a range of brands and products that are simply world-class. A pan-India presence representing the best brands from the automotive world, Anand is the definitive market leader.
The partnership model lies at the very heart of Anand's success, its leadership, its growth. Not only do the partnerships span cultures across the US, Europe, and Asia, but our partnerships have flourished and stood the test of time. Our customers operate in the most demanding and competitive conditions, and we collaborate with them closely to provide the best solutions to their challenges. We are very proud to be recognized every year by our customers.
We at Anand are committed towards ensuring that we are first time right, every time right, with zero accidents, zero defects, zero waste, and zero broken commitments.
Business is 90% people. This is our guiding principle towards our employees since inception. Anand is known in the industry as an HR innovator and has been at the forefront of HR practices for decades. A testament to this commitment is many Anand Group companies featuring consistently as great places to work in India. Collaborating with its partners, associates, and corporates with shared dreams and values, SNSF has since its inception touched the lives of millions of underprivileged men, women, and children in the areas of education, skill development, health and hygiene, and community conservation. Anand is defined by a value system also called the Anand Way. These core values govern our decision-making in every sphere of our work and social responsibilities, and they continue to define the way Anand does business.
We drive Anand as a unified corporate entity.
We aspire to be a world-class organization.
We encourage organizational transparency.
We value integrity.
We encourage innovation.
We nurture talent.
We support continuous education.
We build trust and empower people.
We practice open and honest communication.
We recognize and reward achievements.
We are an equal opportunity employer.
We are committed to social responsibility.
birds find a shelter during the rain, but the eagle avoids the rain by flying above the clouds. Problems are common, but attitude makes the difference. This is what we believe in at DIEMS and say, let us rise above the rest. In pursuance of excellence in the field of technical education, the Marathwada Shikshan Prasarak Mandal, one of the leading educational trusts imparting quality education to more than 1 lakh students every year, entered the field of professional education on its Golden Jubilee celebration in the name of the Deogiri Institute of Engineering and Management Studies, Aurangabad. Started with 300 students in 2009, it has grown to over 3,000 students offering technical and management education with ultra-modern infrastructure and facilities. It is recognized amongst the top 100 private engineering institutes across India by Times Engineering, which is a Times of India initiative. The institute is approved by the AICTE, accredited by NAC, and affiliated to the Baba Saheb Ambedkar Technological University, Lonere, Raigad, Maharashtra. The institute offers an industry-oriented syllabus, internship from the first year itself, gives a choice of open electives from the second year, and 6 months of industrial training in the final year, enabling students to develop knowledge as per industrial requirements. The institute offers the BTech and MTech courses in various disciplines like mechanical engineering, electronics and telecommunication engineering, civil engineering, computer science and engineering, as well as a master's in business administration. Leaders become great not because of their power, but because of their ability to empower others. Creative learning, personal attention, individual counseling, and valuable guidance open up a world of new ideas, which infuse the motivated students and staff with positive energy and creative thoughts. This can be expressed as a unique equation. DIEMS is equal to discipline plus academics plus placements. Why DIEMS? There are more than 40 spacious and well-ventilated classrooms which provide a healthy environment for innovative classroom learning. More than 60 well-equipped laboratories with best-in-class equipments meet not only the requirements of the syllabi, but they are also intended to give practical experience to the students. The students here enjoy the fun of performing various scientific experiments. Playing with various circuit components and seeing how they work in real time is the best way to learn. Competent teachers demonstrate the experiments in the labs, and the students get opportunities to explore inside and beyond the classrooms. These labs provide the facilities for performing practicals on the related concepts on each subject. There are updated software and equipment for the different subjects. Here, the future engineers experiment with, test and prove theorems. Every laboratory aims to prepare students with the knowledge and ability to improve, evaluate, design and control sustainable and cost-effective technologies in order to make innovative and useful contributions to humanity. In order to ensure that the students are well aware of the required industrial standards, not just theoretically, but also in practice, we at DIEMS have a fully equipped central workshop. Here, the students are not only informed about the various stages in the making of a job, but they also get a chance to perform all these jobs on the shop floor. The students complete their projects in the workshop for vehicle manufacturing and assembling of parts. Here, we make sure that our future engineers never miss out on the finest details regarding the various elements of manufacturing. The Institute's library is enveloped in a serene atmosphere. It has a spacious reading room and serves the students and the faculty with more than 30,000 reference books, periodicals, magazines, newspapers, and journals. Our digital library provides the students with online books and e-journals, articles, video lectures, manuals, and many more. It also provides updates, study material, and databases on a large scale, all of which support the academic curriculum of students. Our students enjoy the facility of an elegant seminar hall for conducting guest lectures, training programs, and technical events. The spacious conference room is outfitted with presentation technology for conducting conferences, meetings, and presentations. To meet the requirement of activity-based programs, short-term training programs, and technical workshops, 2 distinct seminar halls have been provided. Understanding the dynamics of industrial expectation at the national and international levels, this year the students have been trained by companies like TCS, TechRel and Barclays. The highest number of job offers was achieved in 2019, with offers from companies like Byju's, Wipro Technologies, Reliance Jio, Atlas Copco India Ltd, Dhoot Transmission, Jaro Education, Hire, Sintel and many others. The highest compensation package offered was 9 lakh rupees per annum. The girls as well as boys hostels of DIEMS is located in a safe and secure campus, and it is indeed a new home away from home. Strict rules are followed and discipline is not compromised. The mess is a great place where food is cooked to perfection and where the homemade flavors and tastes and affordable prices are a hit with the hostelites. Well, the canteen is the favorite place for the students to relax from their hectic schedules. It is also the best place for students to mingle in groups. We encourage our students to excel not just in academics but also in sports. Situated in the center of our campus is a vast, lush green playground where students can bring out the athlete in them. Under the NSS activity, the students take concrete steps to discharge their social responsibility by performing various activities like organizing tree plantation drives and blood donation camps, check dam construction, and conducting street plays. The institute has also adopted a village, Sultanpur, under this initiative and are educating the local people every year about critical subjects like water conservation, environmental awareness, and child education. The college frequently takes the students on industrial visits to various companies with the objective of providing them exposure to real-world problems and inculcate a practical approach. More than 500 industrial visits have been arranged so far. DIEMS has a strong network with the corporate sector, professionals and industrial experts and regularly hosts expert talks with the noble intention of keeping the students updated with the latest trends and practices in the industry. More than 350 expert talks have been arranged annually. As a part of Industry Institute interaction, 102 of our students worked in the industry on 34 live projects under GIZ initiative. To develop the students' sometimes enigmatic personalities, there are 20 active clubs in the institute. The Deogiri Cycling Club has completed an arduous expedition from Jammu to Kanyakumari, giving the message "Save the Girl Child," and another expedition from Aurangabad to Bhutan, which had the message "A Pollution-Free Asia." The Red Hat Academy helps students differentiate themselves by providing enterprise-ready Linux and open-source advanced training, which develops skills that are in demand. More than 150 students have been certified so far, and more than 50 students have got jobs in open-source technologies. Show 2019 was a one-of-a-kind exhibition project in which the projects were prepared by first-year engineering students under the course Engineering Exploration. These students generated 35 great ideas, worked on 12 need statements, and developed 60 projects along with the final year students who exhibited their lab-to-land projects. More than 6,000 visitors visited this mega event. Recently, the Institute had organized the flagship 4th International Conference on Computing in Engineering and Technology. Here, researchers, engineers and scientists from around the world participated and presented their research papers, which were published in the AISC series of Springer. The Institute is well known for its dazzling academic records. The students have brought glory to the Institute with consistent performances in the university exams by securing top ranks in the merit list and setting new benchmarks every year. We have excelled with flying colors in technical events as well. Team Dynamic Boosters won the General Championship in the Student Kart Design Challenge Season 2, held at Hyderabad, and also stood second runner-up in the Bharat Formula National Level Go-Kart Championship held at Coimbatore in March 2019. The all-girls team Tejaswini got the Best Cost-Effective Report Award and Visionary Award in the Saur Urja Vehicle Challenge held in March 2019. Recently, Team Bhumiputra won the Best Innovation Award for the Onion Harvester in the event TIFAN organized by SAE India.
A college is marked by its multifaceted cultural events that include its annual social gathering. Eminent personalities from the civil services and the industry are invited as chief guests, and they are invariably a great source of inspiration to the youngsters. The festival includes various events where the students are given a unique platform to think, step forward, and showcase their talents. This event has its own color and is very unique in its own way. This year too, we celebrated Quasars 2019 with the unique theme of patriotism, dedicated to the brave Indian soldiers who sacrificed their lives during the Pulwama attack. Financial support of 5 lakh rupees was given to the families of the martyrs. DIEMS, providing education ingrained with moral and social values to bring out the youth as professional and responsible citizens with character and humility beyond compare. DIEMS, an institute where the sky is not the limit, and so we say, let us rise above the rest.
Hello, my name is Vinayak Podar and I'm from Computer Science Department. I recently got placed in Byju's Think and Learn Private Limited through the campus placement drives. So, along with the technical education, the social skills also need to be developed equally. And for this, the college has been striving hard by keeping events such as Inspire Talks, because of which the students are getting more connected to the industry and the industry people. So, thank you, Deogiri Institute of Engineering and Management Studies, for providing me with such a great opportunity to me and all my friends.
Hello everyone, my name is Vaishnavi Soronke and I am a computer science graduate from Deogiri Institute of Engineering and Management Studies. Today I am placed in ASP OL Media Private Limited and the credit for this goes to the college. The college conducted aptitude trainings and soft skill programs for the students and I feel proud and privileged to be a part of DIEMS family. Thank you.
Hello everyone, I am Duip Kohli from Mechanical Department and I am from Bombay. I have selected this institute because of its unique features like the mentor-mentee scheme, which develops a strong bond between the students and the teachers. And at the same time, it also allowed me to participate in various competitive events, and also it given me the opportunity to participate and be shortlisted in various multinational companies like John Deere and Cummins.
Hello, I am Swati Kakre, pass out from DIEMS, currently working in a Microsoft as an associate consultant in data and AI. And I would like to thank DIEMS for their cooperation and support.
Hello everyone, my name is Aditya Konarde. I am a site reliability engineer at Red Hat, Germany. I am a computer science engineering graduate from DIEMS with the batch of 2017, and I thank the college for their continued support and engagement.
I'm Purnima Zalde. I'm civil engineer passed out from DIEMS. I'm currently working as environmental health and safety officer in MAT construction in water division. And I thanks DIEMS for their valuable inputs, support and guidance.
Hello, this is Yogesh Gawande, BE Mechanical from 2018 batch. I have started my own startup company when I was in second year in DIMS. I would like to say that DIMS is a very good institute for aspiring engineering students. It has all the facilities to meet the needs of students. I am thankful to management and DIMS family. Thank you.
Hello, I'm Saidi from BECSC 2018 batch. Currently, I'm working as Associate Quality Engineer at Red Hat Bangalore. I would like to say that the institute has been very supportive and has played a phenomenal role in my success. I would like to thank the DIMS family and feel immensely proud that I got a chance to be a part of it.
Good afternoon to all the participants and speaker. On behalf of Deogiri Institute of Engineering and Management Studies, I welcome you all for the webinar on Vehicle Suspension System and Design, organized by Department of Mechanical Engineering, Deogiri Institute of Engineering and Management Studies, in association with Gabriel India Ltd. Gabriel India is a proud member of Anand Group, known for its hard work and commitment from being a single product company in 1961, they have transformed them in line with the changing market, technical and social trends. Their robust design and engineering capabilities have helped their client meet the evolving technological needs of the automotive industry, creating lighter, more fuel efficient, long lasting vehicles, thereby ensuring passenger comfort and safety. Their business units include two and three wheelers, passenger cars, commercial vehicles, and railways. Gabriel India Ltd is recognized as one of the best places to work with capability of producing one shock absorber per second with more than 3,000 employees. Their intensive effort in the field their intensive effort in the field of research and development has been recognized with awards such as prestigious Golden Peacock Award for Innovations, and the same results in more than 43 patents filed across products and processes. Now, I would like to request Professor P.G. Taur, sir, Head of Department, Mechanical Engineering, to kindly introduce Mr. Rajendra Abhange, sir. Over to you, sir.
Thank you, Amitpal. Am I audible, Amitpal?
Yes, sir, you are audible.
I'm audible?
Yes, sir.
Yeah, thank you. Thank you, Amitpal. So, good afternoon to one and all. It's my honor to introduce today's guest, Mr. Rajendra Abhange, sir, Senior Director and CTO, Gabriel India Ltd. He is a fellow in mechanical engineering and certified chartered engineer, having core strengths in automotive business management, strategic leadership, customer relationship, new business acquisition, product technology, innovation, lean manufacturing, and operations, etc. He has also an experience over 33 years in production planning, operations, strategic project, technology transfer, product strategy, industry automation, human resource, and many other leadership roles. He has several technology patents and earned a national award, including most prestigious Golden Peacock Award. He has also a global level speaker, often conducting workshops on advanced technologies such as e-mobility, autonomous driving, system safety engineering, and advanced suspensions. Now I request Abhange sir to take charge over. Abhange sir, please.
Thank you, Professor. Thank you, Amit Pal. Am I audible?
Yes, sir. Yes, sir. You are audible,
share
sir.
My screen. I will share my screen in a short while.
Abhange sir. Abhange sir. May I
Yes.
please stop you for a second?
Yes.
Sir, now, 1 minute, sir.
Yeah.
Okay. Now, let me first introduce to you to all our director.
Amit Pal, you carry out with Amit Pal.
Yes, sir.
Amit Pal, you carry out with Abhange, sir. Now the flow should be continued.
Amit, I have to leave the event in 10 minutes. That's why.
Well, that's why I'm saying Amit Pal.
Okay, sir. No problem.
Amit, I'm just trying to share the screen. Okay.
1 minute, sir.
Yeah. Is it visible? Can you?
Can you please press the share screen button below the screen?
Yeah. I have already shared that.
And after that, you need to that application window and select the PowerPoint presentation that you want to share.
Okay. Got it.
Yes, sir.
So, Welcome to this wonderful event, which is my always pleasure to be amongst the young students, because I feel whenever I am with you, most of you, and I believe you have a large audience today. I'm not going to talk about shock absorbers, okay? I'm going to talk about what revolves around shock absorber for the next 5 to 7 minutes before I hand over to my young and team. Both of them are already here, Ajay and they will take over from the next few minutes. You know, I just want to take you to a little past history that most of these gadgets we would have used in our lifetime, but today they don't exist anymore, right? So, what has happened all of a sudden? Have you stopped listening to music? Have you stopped getting the documents printed? Are you not talking on telephones or mobile phones, or what is happening? But something has happened. And here are some of the devices or gadgets that are likely to be not there, including services like driver. You may not have the driver, like cigarettes may not exist. Engines may vanish. We all were born with engines, you know. We studied, I am a mechanical engineer from Government Engineering College, Aurangabad, and this engine was my favorite topic. But today we are talking about engines vanishing. What an amazing thing. So all these are things are going to happen. So what is behind all this topic is that what happens is that when the things get obsolete, you know, first of all, there is nothing eternal. There is nothing forever on this planet. Everything has a life. And most of the time, when the products are unable to provide an attractiveness in cost value relationship, in comparison to the other options, the product vanishes. For example, cassette player. It was not able to provide the cost value relationship compared to the new generation of listening to the music. First of all, FM came, and then you had CD players came, and then you had iPods came, and now everything is gone and everything is in your mobile. Smartphones came. So things do remain forever, but the way you use things, they change. And that is typically in the economic language is called as cost value relationship. So the Moore is one of the scientists, and Metcalfe is another scientist, who put two theories that if you are continuously enhancing the performance of your product linearly, the cost has to go down linearly. It's a very radical thinking, isn't it? Normally you go to the market and ask for something superior, a better shirt, they say it's going to cost you more. But here, Moore said, if you want to stay alive in the marketplace, you have to enhance the performance while reducing the cost continuously. And the relationship has to be linear upward and linear downward. On the other hand, Metcalfe brought another model that it's okay that if sometimes the cost of the product goes up, but then the value has to go up exponentially high. Then you stand a chance to survive. And Gabriel has been following these models for now over 5 or 6 decades. And that's why we are the oldest company in India that still survives in shock absorbers. Otherwise, many companies have come and gone. Why do we stay alive is because we follow both the models, Moore model and Metcalfe's model, in our business, so that our products are continuously demanded by the market and they don't get obsolete. Other topics is that this is the chart from IBM, and I'm showing it for last 10 years. Okay, it's available on the net. That what are the changes, external forces that are going to impact our industry? So technology continues to be one of the major topics that impacts the industry. But look at the other indicators. Sustainability was in 2008 had only 33% as an index, gone up to 60%, which all means that carbon footprint, reduction of weight, reduction of wastages, reduction of poisonous emissions, everything counts in the future. If your products are associated with these kinds of hazards, then believe me, your business, your products will not exist anymore. Why BS6 has come? Everything is gone. Whatever was produced in BS4 is no more possible to sell. There are trucks lying, there are cars lying, in the yards with the dealers who do not have buyers because they do not meet the new BS6 norms. So remember, in any business you are, any service you are, if you are not able to handle the sustainability concerns, your product will is under threat. Also, the automobiles have evolved over the years, right from the first automobile 1908 and 1905. The first automobiles were built and Ford did mass production of that. From that time today, there is a huge change. In those years, people were preferring horses over automobiles because automobile was a bigger problem. They were not fast enough. They were consuming a lot of fuel, not very economical. Horses were very handy. They would go any nook and corner. So people said this automobile is a useless thing to have, and horse is a better thing to have. But then today you see, where do we stand, and way forward in the right top box, you will see a future which will not have a steering wheel, which will have nothing inside. Okay, just like you're sitting in your living room or in your bedroom. Okay, you will have all the gadgets because cars will be driverless. And I just got a call last week from one of my old colleagues from the Silicon Valley that there is a NIVO there is a company called NIVO who has already got a license of a truck for a delivery truck, which is driverless, which does not have a driver and which can fly on the normal road. So these are some of the disruptions that are happening around you and surrounding all of us. And we have to be a part of this disruption. Also remember that the aging population of the world population is continuously growing. So there is the demand is going to continuously grow. Today we are at 8 billion. And sorry, I'm showing a wrong slide. Today we are somewhere around 7.4 billion by 2020. This population by end of the century will be 11 billion. Obviously, the demand will be more and the consumption of everything that we produce on this planet is going to go up. Also, the automobile requirements is going to go up. India has currently only 30 cars per 1,000 people, or less than 30. China has got 150. America has got 800. So if we are able to get even to the level of China, around 150, India's roads will burst with automobile. There will be no roads to travel. There will be no roads to park the car. Okay. So all these disruptions that are happening around us, including the mobility index. The global mobility index is going to be another topic that people would like to have more mobility options. Like in Aurangabad, you have only city buses and auto rickshaws. You don't have so many Ubers probably, or you don't have trams, you don't have metros. So your mobility index will fall very, very low on this scale. But cities like Stockholm, Amsterdam, Hong Kong, there are multiple ways. In Hong Kong, you can go in ferries, you can go in trams, you can go by sky train, you can go by metro, you can drive. There are n number of options to commute these distances. So the global mobility index is also going to be a very huge topic, which is going to disrupt the entire auto industry. Why I'm telling you, I just wanted to create a background. Before my team, who is a very young and very dynamic team, who's going to give you a wonderful presentation in next few minutes, I wanted to set the context for that. So I will be back into this conference for question and answer session if possible. In the event I'm free. Otherwise, we will be seeing you next time at some point of time. So good luck to you and have a great time in the event for the next 45 minutes to 1 hour. So it's over to you, the organizers, so that my team can take it over.
Okay. Thank you, sir, for your words. Now, before we go further, I would like to introduce our director and visionary leader of our institute, Dr. Ulhas Shiurkar, sir. Dr. Ulhas Shiurkar is the director of Deogiri Institute of Engineering and Management Studies since its inception in the year 2009. Sir is an academician with 34 years of experience in industry and education. He is a member of Academic Council of Dr. Babasaheb Ambedkar Technological University, Lonere, Sir is also a member of various committees of Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad for Board of Studies in Electronics Engineering and the coordinator of Faculty of Engineering and Technology, Dr. Babasaheb Ambedkar, Marathwada University, Aurangabad. Sir has authored more than 20 research papers in national and international journal and also authored 3 books in the stream of electronics and instrumentation engineering. Some of the awards and achievements under his name includes, under his leadership, the institute is ranked among top 100 private institutions across India by the Times Group, Seva Gaurav Award by Marathwada Shikshan Prasarak Mandal for the year 2014, Engineering Watch Eduprevious Award in the year 2013 for contribution to the engineering education, Best Teacher and Guru Varya Award in the year 2010 and 2011 respectively by Rotary Club of Aurangabad. Now, with this introduction, I kindly request our director, Dr. Ulhas Shiurkar sir, to kindly say a few words for this session.
Yeah. Very good afternoon to all of you. Amit, I'm audible?
Yes, sir.
Mr. Abhange, who is my friend and senior to be for engineering by 1 year. Mr. Ajay, Mr. Geetika, the head of the department, Prakash Taur, Amit Pal Singh, Gopekar, all the faculty members, and the participants. We got a good response all over the India for this webinar with vehicle suspension system and design. I am not a person from mechanical engineering side, but it's very sure that there are lots of changes. What Abhange sir told over the disruptive technology, the challenges and everything. There might be the IC engine might be obsolete if the introduction of the electrical vehicle. Majority of the industries are working with electrical vehicle. But one thing is very sure, whatever the type of the vehicle, the suspensions will be there. So suspension, without suspension, the vehicle not will run, and there are good careers and opportunities with suspension design. Today we are having very 2 young people, especially thanks to Geetika and Ajay, because I talked with Abhange sir, and then he told me that yes, these are the 2 young smart people are with us. They will be sharing their knowledge. Thank you to Gabriel, thank you to Abhange sir, thank you to Geetika and Ajay. Thank you to Mechanical Engineering Department for arranging this webinar. Thank you. Wish you all the best. Thank you.
Thank you, sir, for your kind words. Now, moving further, now we have 2 more speakers with us, Mr. Ajay and Ms. Geetika. First, I will introduce their profiles. Mr. Ajay K is the Assistant Manager, Research and Development Department, 2-wheeler and 3-wheeler Division, Gabriel India Ltd. He is an automobile enthusiast with a passionate motorcyclist with experience in vehicle dynamics. He started his career in Gabriel India Ltd. from the year 2008. He is currently handling vehicle dynamics, ride and handling testing, suspension tuning, and testing of 2-wheelers and 3-wheelers. He is professionally trained motorcycle rider and has experience on many tracks, including a few of overseas tracks. Now, with us, our second speaker today is Ms. Geetika Jayaram. She is a senior engineer in Research and Development Department in 4-wheeler Division. She is an automobile enthusiast with passion for research, and also she is a former participant at SAE Baha. She finished her bachelor's in mechanical engineering and joined Gabriel India in the year 2008. And currently, she is a part of engineering services at Research and Development, R&D handling, CAE, and road load data acquisition projects. With this, I request our speakers, Mr. Ajay, to kindly start with their presentation.
Geetika will be starting the presentation, and then it will come to me. This is the plan will be working.
Okay, sorry, sir. Ma'am, you can start the session now.
Thank you, Amit sir, for your introduction. So let's begin our topic of vehicle suspension system and design. So today we will be covering topics of basic overview of the suspension system, then what is a shock absorber, the interaction of suspension with vehicle, at vehicle level what does the suspension exactly do, how the shock absorber controls vibrations during running of the vehicle, and advanced technologies that are coming up in suspension. Now, if we go back to the basics, what is a suspension system? It is basically a mechanical system connecting your wheel and axle to the remaining chassis of the vehicle. So your entire system can consist of suspension springs, shock absorbers, along with the linkages and wheel assembly. So here you can clearly see a quarter car model for a four-wheeler and the front suspension for a two-wheeler. What are the important functions of the suspension system? Main function is to isolate the chassis from the vibrations which come onto it due to the road undulations. Next, to keep the tires in contact with the road at all running conditions, to reduce the roll and pitch movement of the chassis, to support the vehicle height at all conditions. What are the different types of suspension system? If we broadly classify, suspension system can be classified into two types: dependent suspension and independent suspension. Dependent suspension, as the name suggests, both two wheels, either of the front or rear, both move together. There is transfer of load from one wheel to the other, and no wheel has the ability to move all by itself. This kind of suspension is usually used in heavy trucks and off-road vehicles because of its high load carrying capacity. So here you can see the example of a beam axle type of suspension. Next, moving on to independent suspension. In independent suspension, each of the wheel can move independently off of each other. Their motion does not depend on the adjacent wheel. This independent suspension improved the vehicle ride control as well as comfort. And the most commonly used type of independent suspensions in four-wheelers are McPherson Strut and double wishbone type of suspension. It is needless to say that in two-wheelers, both the wheels move independent of each other, hence it is independent type of suspension. So moving on to the most popularly used type of suspension in front wheel of a four-wheeler is the McPherson Strut. In this, as you can see in the figure, the damper as well as the spring is combined into one single unit. So as both of them are combined together, the package is very compact and light in weight. As there are lesser number of parts, you only have the triangular link, which is the lower control arm, and the McPherson strut present. It gives you good serviceability. Then if you know, in double wishbone type of suspension, there is another wishbone which is present just to carry the loads. As in this case, that is absent, your strut itself becomes a load carrying member. Hence, large loads are applied on the body via the top mount of the strut. Next is the double wishbone type of suspension. Here, as you can see, there are two wishbones, the upper and the lower one. The damper is connected to the lower wishbone, and this is connected to the chassis at 4 points. Here also the spring and damper are combined together into one compact unit. But as you can see, there are more number of parts. Hence, the replacement and service costs are high. It's more complex in shape and it is higher in weight as well as compared to McPherson Strut. If we go on to two-wheelers, in front suspension, you have the telescopic front fork. It is the most commonly used type of front suspension in two-wheelers. It contains the damper and the spring packed as one single unit. Most of the advantages are it is very simple in design, it is very easy to manufacture and assemble, and it is lighter than the older designs that were used in two-wheeler front suspension, which consisted of many linkages and external components. Next comes the inverted front fork. In case of inverted front fork, as the two figures show, you can see that the portion with the larger outer diameter is connected onto the wheel in case of usual front fork, and in case of inverted front fork, it's vice versa. So the advantages hence are increased rigidity due to larger outer diameter clamping, increased inner tube overlap, better handling due to reduced unsprung mass. We will get to the concepts of unsprung mass and sprung mass and its effect on the vehicle in the later stages. and fine tuning of damping due to cartridge type of design. Next comes the rear suspension in case of motorcycle. So here you have multiple options. One, you can have a single twin tube shock absorber. So that is called as the twin tube hydraulic shock absorber. Else you can have two shock absorbers in the rear, which is both of them are twin tube hydraulic shock absorber. And then there is another type, which is the canister gas type shock absorber. So here you can see an additional part, which is called as the canister, which usually consists of nitrogen gas, compressed nitrogen gas, and there are other varieties of canister type of gas shock absorbers as well. Now you could see that in all cases there was the shock absorber which was there in common. So what is the shock absorber exactly? It is a hydraulic pump like device. It is mainly used to control the impact and rebound movement of the vehicle. The key role of the shock absorber, as the key role of the suspension also it is, to maintain the vehicle's tire always in contact with the road. So this will ensure safest control and braking response from your car. What is the basic principle behind the working of the shock absorber? So as the vehicle moves on a road, the shock absorber gets compressed or extended in case of any undulations on the road. So this, in the form of kinetic energy, gets converted into thermal energy inside the shock absorber. For this purpose, the fluid which is present inside the shock absorber is forced to flow through restricted outlets and valve systems. Thus, a hydraulic resistance is created. So what are the different types of shock absorbers? You have, the first type is monotube shock absorbers. Here, as you can see, you have a piston rod, a piston, and a oil chamber. Then you have a floating piston, which is denoted as E, and you have a gas chamber. So here, you only have one single tube carrying the entire oil. You have two strokes, the compression stroke and the extension stroke. Both are controlled by the piston itself, and the gas chamber is present for compensating the oil flow and for better response of the shock absorber. Next comes the twin tube shock absorber. So here you have two different oil chambers. So you have two tubes, the inner tube and the outer tube. The remaining components, which is the piston valve and the piston rod, remains the same. As there are two tubes present, you have additional component named base valve which comes into picture. In the previous case, as I had mentioned, the piston itself controls the extension and the compression stroke. Here, the piston controls the extension stroke, whereas the compression stroke is controlled by the base valve. So what are the basic components of the shock absorber? You have the mountings, which is the upper eye ring and the lower eye ring, the piston rod, the rod guide subassembly, you have the inner tube, outer tube, the piston subassembly and the base valve subassembly, and a recoil bumper. A recoil bumper is basically used to avoid metal to metal contact during full extension. So Ajay, over to you.
Thank you, Geetika.
Yes, sir.
Yeah,
Yes, sir.
it was a wonderful presentation on the basic of suspension. Now we'll move on.
Yes, sir.
Sorry, I just moved a bit quicker. Okay. Okay. So in the past session, we understand what a suspension does and what is the basic working principle of a shock absorber and what are the different
Yes, sir.
Yeah.
Presentation is not looking properly. Now it is visible. Go to presentation mode now.
Okay. Is it so?
No, not
It's
clear.
not visible.
Just a second.
While going in, you start the presentation from the beginning and then move to this slide.
Okay, right.
Yeah. Share again, please, sir.
Yeah, I'm just sharing it. Is it visible now?
Yes, sir. Now it is visible.
Right. Okay, thanks for that. Okay, in the last session, we understood what shock absorber does, or what is the working principle of a shock absorber, and what are the different types of shock absorber across the industry. On this session, we'll try to understand. I have some. Okay, yes. We'll try to understand the role of suspension in vehicle dynamics. This is the overview what we're going to learn in this session. Starting with the vehicle dynamics overview, and we'll move on to a quarter car model, and then into a half car model, followed with a full car model, and the finishing stage will just touch upon what is ride tuning and how the suspension tuning has been done in the general practice. So when we talk about vehicle dynamics, one should understand what is vehicle dynamics. The vehicle is a mass which is moving along a surface. So the vehicle dynamics term itself, how to control the mass on a motion with respect to the boundary condition consideration of the driver input and the road surfaces. These are all dealing with the vehicle dynamics. Okay, now when we say vehicle dynamics, it's associated with a motion. We should understand what is the degrees of freedom, because to have a motion, you should have a degrees of freedom on the vehicle. Then we consider here 6 degrees of freedom model as a basic version, and it remains same for both two-wheeler and four-wheeler, which will have 3 linear motion along X and Y and Z, and also 3 rotational motion along X, Y, and Z. This will look into detail on the following slides. Okay, so how the vehicle dynamics are classified with respect to the axis system. What about the motion along the Z axis? We call it as the vertical plane, is classified into vertical dynamics. And the components which is controlling the vertical dynamics are shock absorber, sprung mass, seat, and vertical tire characteristics, etc. Then it comes to the lateral direction, which is along the Y, which is classified as a lateral dynamics, where the suspension geometry, steering geometry, and vehicle layout, center of gravity, roll center, etc. contributes on deciding the lateral dynamics characteristics. Similarly, along the vehicle, which is on the X-axis, whatever the dynamics are considered is called longitudinal dynamics, which includes power transmission, braking, and center of gravity, position of X-axis, and wheelbase, etc. Okay. Now, from this slide, it is very clear that shock absorber is majorly contributed on the vertical plane or in the vertical dynamics, and 3 kind of degrees of freedoms are controlled majorly by shock absorber, which entails bounce, roll, and pitch. So in upcoming slides, we'll be looking into how these 3 modes are being controlled by a shock absorber system. Okay, we'll start with the vertical mode, which is the bounce mode. To understand that better, we should understand what is a quarter car model. In a quarter car model, typically there are 4 components called sprung mass, which is illustrated as MB, and unsprung mass, which is illustrated as MW, and sprung mass, spring, and a damper system. So we know the sprung mass is all the masses which is above the spring, which includes the passenger and driver mass and the vehicle mass itself and a portion of shock absorber mass. And coming to the unsprung mass, which includes the wheel assembly mass, wheel assembly weight, and portion of suspension, and the portion of swing arm, and the brake assembly units. So this comprises the unsprung mass. Then another 2 components are spring and damper. The left side bottom corner, there are 2 graphs which displays how a spring controls the motion and what is the role of the damper. We'll look into the details of it on the next slides. Now let us consider a real life scenario, a wheel which is wheel with a mass upon it, which is going to face the hump. Let us consider the first scenario where there is no spring and there is no damper on it. Look at the green line, which is the traction point of tire, and the red line is the center of mass moving with respect to the tire movement. You can clearly see there are 3 things we have mentioned here. The moment it reaches the obstacle, the moment it hits the obstacle, the wheel is going upward, and the same fashion, the sprung mass also going upward, or the slope is very steep, which is going to have high acceleration level on vertical plane, which causes a very fast ride to the radar. But that is not the limit, not the end of it. You see the back side of the bump, the green line, which is having a gap from the bump profile. That means there is a severe loss of traction on the back of the bump when no suspension system with a mass hits the bump. And also, after landing the vehicle, or after landing the wheel on the ground, there is uncontrolled oscillations on sprung mass as well as on unsprung mass. Okay. Now let us understand the second scenario where I am just putting up a spring into the system. Now we can clearly say it's a sprung mass system. There is a mass on the spring and there is unsprung mass. So the difference is majorly the moment you hit the bump, the acceleration, the upward movement has been smoothened, and so you don't feel such a harsh ride during the hitting, but still the traction is not so good on the back of the bump, and there is a uncontrolled oscillations. Now let us see the third scenario where there is a spring and damper system in place. This is a perfect requirement of a spring mass, a spring damper system, where the traction is into the maximum and the smoothest ride can be obtained. But the question is it possible on the real life scenario? Actually speaking, no, with a passive suspension system, because the suspension is not just designed to have only the vertical plane, it also to contribute on other kind of motions, other degrees of freedom. So there will be always a trade-off between some other characteristics. So in real life, we may not get a smoothest ride as it is in a passive system, but in active system, yes, you will be getting the similar. Okay, now we are done with the quarter car model. We have to move on to the half car model, where we'll understand the pitching motion. When it comes to the pitching motion, generally all the suspension designer will be facing a problem of synchronization. Okay, before that, we'll understand what is a half car model. You have a two-wheel assembly and the two suspension systems, front and rear, and the sprung mass is connected to both. So in this scenario, the front wheel will be hitting a bump in first and the rear will be hitting the bump on second. When the synchronization is not good, even after leaving the bump track, you will be feeling the front and rear pitching motion, which is not in sync. To get the sync back, generally what designers do, the rear stiffness of the suspension will be increased, or rather we say the ride frequencies will be increased by 10 to 20% compared to the front, so that you will get a flat ride after the bump. Another pitching motion we'll be discussing here will be a squat. Squat is nothing but the load transfer from front to rear when vehicle is accelerating. This generally happens when you have very high level of acceleration on the vehicle. And you see, I'm demonstrating all this squat or pitching motion in a motorcycle because it's very significant in a motorcycle system rather than a four-wheeler system. There are a lot of reasons for that, but we are not going into the depth of it. So the squat can be controlled by adjusting suspension characteristics and anti-squat geometry. Increasing rear suspension stiffness will help you to reduce the roll, and also introducing an anti-squat feature, which is demonstrated as a diagram here. It will also help you. It's a feature created by the rear swing geometry, chain layout, and center of gravity height and wheelbase. So having a good amount of anti-squat, like say 100%, you will have a less load transfer to the rear, and thus you can reduce the squat. But some people will be using the squat as a required feature for those who do the stunts kind of wheelies. Okay, now we'll back into the another pitch motion is called dive. Dive is opposite to the squat, where the front will be loaded and the rear will be unloaded. This generally happens when you do a braking. And anti-dive is the thing which you can use it for controlling the dive feature. There are linkage mechanism will be used in earlier scenarios to control the dive, but whatever the telescopic front fork we are using in the real life scenario or the current scenario, it is having a pro-dive characteristics, or other words, it is having a negative anti-dive characteristics. this is generally used to have a better braking force. Now we are done with the half car model or motorcycle model. Now we'll go into the full car model or four-wheel model, where the roll comes into the picture. The roll is nothing but created by the rolling moment, and higher the roll angle, it creates the incidence of rollover. So to control the roll motion, generally we might have to optimize the distance between the roll center to the CG, and the shock absorber, increasing the shock absorber stiffness also will get you some torsional stiffness, will control the roll. And the final answer for a roll control will be a anti-roll bar. So this is a typical example how the roll will happen on a four-wheeler. Okay, we are done with the vehicle dynamics theory. Now let us understand some practical applications of it. Generally, we set the suspension by design, and there will be a testing phase of it, and most of the industries follow the same procedure. This is called right tuning and suspension setting phase. So before going to the right tuning, we should understand two important things. One of it is what is expected. What should be the expectation from the suspension tuning? The first point is you should be able to define the requirement of ride and handling characteristics of your vehicle, because each type of vehicle will have its own different kind of ride and handling characteristics. And the second point is the ride comfort and handling is in opposite phases for a passive suspension system. So a tuning exercise is to optimize the both in accordance with the vehicle category. So the blue line is the lane of comfort and the orange line is lane of control. For a soft suspension, you might get a pretty comfortable ride, but the handling will be poor. And the stiff suspension, up to some extent, you will get a maximum control and handling. So the green zone, which is mentioned here, is the zone of tuning. You have to select which area you have to optimize the suspension, and we have to tune accordingly. There is a methodology of suspension tuning. The general practice is a two type of suspension tuning. One is a subjective testing and another is objective evaluation. In subjective testing, we tune the suspension with respect to the rider feeling, or it is also called rider perception. And since the suspension of the ride comfort is a subject matter, so then for that purpose, we use a standard track with expert riders. Minimum of 3 riders will be driving and giving the feedback independently, and that will be correlated on a later stage. The role of a suspension engineer in the ride tuning stage is to convert the rider feedback to suspension characteristics and tune the suspension accordingly. A typical output of a ride tuning activity is the chart is mentioned here. Is called web chart or radar chart. Here, all the ride and handling requirements are listed on the axis and will be rated with respect to 1 to 10 or 1 to 5 in the scale. Okay, coming to objective evaluation. Now we talk about failing in subjective testing. In objective evaluation, we'll be dealing with some objective values. We'll be looking into some values. Generally, it is done by a instrumentation study. And the values will be looking for ride and handling, how to characterize the ride and handling with respect to some objective value. Some of the example we mentioned here is acceleration level in terms of RMS Gs and transmissibility, or the suspension and wheel travel and VDV, vibration loss value. All these things will define ride characteristics, and there are similar parameters for handling as well. So done with the vehicle dynamics explanation. It's over to Geetika to explain how a suspension controls the vibration with respect to spring and damping mechanism.
Geetika ma'am, please unmute yourself.
Thank you, sir. That was the vehicle dynamics and the right tuning part. Now coming on to the spring, we for so long we have talked about springs and dampers and everything. So what are the characteristics of these particular mechanical components which overall controls the vibration? So in case of spring, you have the spring stiffness. So how much amount of force is required for a unit deflection? That is the spring stiffness. So it is defined as the force upon deflection, but this is something which is calculated practically after testing. So for a normal spring, you have stiffness calculated based on the modulus of rigidity, its wire diameter, the number of coils, and mean coil diameter. And the meaning of all of these terms is represented in this diagram. So what does this spring stiffness variation look like? Now, as you can see in the graph which is in blue, which is at the lower end, has a spring rate of 0.5 kg per mm. And the graph in red has a spring rate of 1 kg per mm. So as the stiffness goes on increasing, the slope goes on getting higher and higher. Thus, your more amount of force will get absorbed in unit deflection. Now, what is damping? As you had seen in one of the graphs, if only a spring were used, you could see that the vibrations continued with a constant amplitude. The reduction in this amplitude of oscillation is what the damper does. So how does it do that? It offers resistance to the flow of oil inside the damper. So how does what parameters offer this resistance, or what components offer this resistance? You have piston and you have some
हो
valves.
जाओ, आप टेंशन नहीं, तुम हो जाओ, बाद में सर आए तो अटक जाएंगे फिर.
So the flow happens through this piston. So initially you have the flow area equal to the inner tube diameter, and then this flow area is reduced to the diameter of the holes. So this causes resistance to the flow. Other than that, the flow happens over these deflection discs. So that is another factor which causes resistance. Now I initially explained that the kinetic energy gets absorbed in the form of heat energy. How is this parameter exactly measured? So we plot a graph of force versus displacement. The damper is given a sinusoidal input for plus or minus x mm, and this plus or minus x for this plus or minus x mm, the damping force is captured, and a potato curve like this is plotted. The area under this curve represents the amount of energy that is absorbed by the shock absorber. The two strokes, the portion of the graph which is above the x-axis is the rebound stroke, and portion of the graph which is below the x-axis is the compression stroke. Now this potato curve is plotted for a constant velocity. If you go on plotting it for multiple velocities, you get a damping force curve versus the velocity, damping force versus velocity curve, which looks something like this. So here the low speed damping controls the vehicle handling characteristics, and the higher speed dampings control the comfort characteristics of the vehicle. Yeah. Ajay, over to you for the gas part.
Thank you, Geetika, to explain about how the damping and the spring works in the suspension system. So I will just take you to another topic, and it's an add-on thing on the suspension system, which is called the gas charging. So many of us have many myths or some misunderstanding about what a gas charging can do in a shock absorber. So the first question arises: why gas charge is required? Okay. So the straight through answer is to avoid cavitation in damper system. But is that just the thing it does to the suspension system in a vehicle? Not exactly. So how gas charging helps you in suspension performance? It reduces the cavitation, yeah, fundamentally yes. Then also it improves the suspension response because there is no lag or something called bubble formation, which will cause you a uneven damping. Then
Ajay,
yes.
Ajay, just 1 second. Your PPT is
Not
not
visible.
shared. It's not shared.
Just a second.
Yeah.
Okay, is it visible now?
Yeah.
Right. Okay. So the first question was like, what is and why gas charging is required? The straight answer was to avoid the cavitation, and how it is going to help you in suspension performance is like reduces the cavitation, and it improves the suspension response and reduces suspension noise, because the cavitation causes a lot of unwanted noise in suspension system, and it's a major problem in four-wheeler types construction for car, and majorly in a passenger car. And also it improves the road holding or traction, because it constantly applies the tractive force towards the road. And the last point, but not the least, it increases the shock absorber life, because the cavitation is always going to reduce the life of oil characteristics, thus the life of the suspension. So this is a typical type of canister shock absorber construction, which is having a gas in the bladder. You can see the nitrogen gas bladder there, which you will be supporting on the compression side of the suspension, compression stroke of the suspension, and the rest of the systems remain same with respect to normal hydraulic suspension. Now, we say the term cavitation, so we should be understanding what is cavitation. Cavitation is nothing but it's simply, we can say, it's a behavior of voids or bubbles in a liquid. It will happen when the pressure of the liquid drops near to the vaporization pressure. So there is a two image I am representing here. The left side one, you can see small bubbles are created at 100 degrees centigrade, and the right side one, the temperature is about 15.5 degrees centigrade, but the same amount of bubbles are created, but only the difference is pressure is far less. It is near to the vaporization pressure of the liquid. So it's about 1.7 kilopascal. So this is the importance of the pressure. Even pressure can create a bubbles or voids in the liquid, which will cause you cavitation, which will cause very uncontrolled motion of the damping. Okay. So this is all about the suspension system and the components of suspension system. Now let us understand what is the new technologies or what are the latest updation is happening in the industry of suspension. To start with, we'll have a look into the new adjustable shock absorber. It's a mechanical adjustable shock absorber. The images are a representative purpose. There are many type of adjustments are available in the market. Mechanical rebound adjuster and compression damping adjuster, preload adjuster, and length adjuster. These are the few typical examples. And the bottom side, the graph, you can see the rebound side forces velocity, how it varies with respect to the rebound adjuster. It will give very low damping to very high damping from the lower setting to the higher setting. Okay, moving ahead. That we were talking about a mechanical adjustment. Now we'll talk about the electronic adjustment, because the whole world is moving towards electronics, and being a suspension manufacturer, we cannot survive without having an electronics into it. So moving towards that, the other mechanisms remain same, but there is a few additional components comes into the picture. There is a switch will be available and goes to the controller as a feedback, and electrical motor responds to the controller feedback, and it adjusts the adjuster mechanism. The rest of the construction of adjusting mechanism remains same. Only this will be additional module for any of the electronic adjustable shock absorbers. Okay, little more in advance. Let us look into the semi-active systems. We must have heard what is a lot of time when we spoke about suspension is a semi-active and active suspension. Since the typical difference between a semi-active system and the active suspension system, semi-active suspension deals with controlling only the shock absorber, or otherwise it's simply controlling only the damping force, where an active system will be controlling the spring system, or will be having an actuator instead of a spring, and the damping system. Okay, how it works here? It's an illustration of that. It's again a quarter car model. You have a sprung mass and wheel just below the spring, and there is a wheel sensor and there is a sprung mass sensor or body sensor, which both will work together. Will understand what kind of track you are experiencing under the tire, and the controller will give the feedback to the damping control unit, and that will control the damping accordingly. This will work with the sensor setting, and generally the acceleration sensors are used here. Then this comes to the active suspension system. There are many types of active suspension systems are available in the market. Just giving a basic example of it. As I told you, active suspension system will also control the stiffness and the damping characteristics. And other things are the same. We'll have a displacement sensor or any sensor at the body mass, and there is a sensor at the wheel. Both together will define what profile you are experiencing on the road. That controller will give the feedback to the actuator. FA is nothing but an actuator which controls the stiffness and the damping mechanism. As I told you, there are many types of active suspension. The sensors are being used in the recent days. The sensors are used for visual mapping or image processing, and also accelerometers on the center of gravity will be using the sensors like gyroscopic sensors. And also there are instead of actuator system, the latest advancement is that electromagnetic suspension straight away. So the controller will give directly feedback to the electromagnetic actuators. So instead of a spring and damper, the electromagnetic actuator will respond to the controller and will give the exact ride. This is also called as a hook type suspension or sky hook type suspension. Yeah. So this is all about the latest advancement, and we are reaching the end of the presentation here. So let us move into the question and answer session, and let us try to answer some of your doubts in this session. Thank you.
Sorry. Thank you, sir. Can we start with question answer session now?
Yeah, good to go.
Okay, sir. We have selected some of the questions that we find here. Just a second, sir. Sir, there is one question. How we fill the gas in the canister type suspension system, sir?
Okay. Okay, I will do one thing. I'll just go back to the slide which I was explaining about the gas charging. Then you can understand it better. Can you see the screen is visible, sir?
Yeah.
Yes, the screen is visible, sir.
Okay. As you can see, the bladder and nitrogen gas is mentioned on this image, and just below the nitrogen gas, there is a cap. So the cap is having a valve called non-return valve. It's a kind of a rubber piece. You can puncture the rubber and you can fill the gas into that. And once you remove the needle out of it, the gas will not leak. This is only one type of gas filling. Generally, nitrogen gases are filled with valves only. There are multiple types of valves available across industry. So this type generally use a rubber valve and puncture it using something like how a bladder of football filling the air. Similar concept. Yeah.
Next question is for Geetika ma'am. Geetika ma'am, how to plot force and velocity graph while designing dampers?
While designing dampers, you cannot plot a force versus velocity graph. That is an output of testing. You can design it for a particular force versus velocity graph, but that is based on your previous experience and knowledge. For example, we at Gabriel have multiple applications, and if we are developing a new application taking reference of some old application, then we already have set values. But if you are somebody from Baha or Supra background, then you will have to get it tested.
I will just add some aspects into that. When you talk about forces with velocity, it's basically how it's respond to the frequency. So it's a deeper topic. We will not be going to that depth, but a broad view I will give you. The right frequencies are generally on the lower side, and there will be high frequency input also coming from the road. So when you plot right frequency versus transmissibility, you will get a changeover point from where the right frequency to the high frequency is happening. So the lower frequency will consider for the lower damping, and higher frequency will be considered for the higher damping. The changeover point can be designed from the vehicle dynamics point of view, and then we'll be defining the damping ratio requirement for the lower velocities or lower frequencies and higher frequencies. It's a very complicated topic, but I'm just giving a broad view.
Sir, there is next question. How to calculate a suspension angle for two-wheelers?
If I'm trying to understand the question, because how to calculate suspension angle for designing the suspension or on the vehicle. If it is for the designing the suspension, there are two suspension systems, front and rear, and both are calculated separately because both functions are slightly different. When we talk about the front suspension or front fork, it is having two functions basically. One is to take care of the road inputs on the vertical plane, and also to give a structural rigidity to the handling part. So there is always angle created by the front fork, which will create whatever the forces coming on the ground will split into two components, which is along the fork and along the bending structure. So it depends on what kind of characteristics you need on the vehicle. Like if you want to have a tourer or you want to have much higher straight line stability, then you should have a very high lean angle with that basically there are two things we'll be considering. Now I'm talking only about the suspension characteristics, and second is the handling characteristics. So handling, when you say the trail comes into the picture, and you need a higher trail to have a higher ride stability. So you will be generally designing a higher mounting angle to get the higher trail. And when you have street biking, which you need a very quick response from the steering, and for any smaller input you have to steer the vehicle on the street, then you should have a very less lean angle, and the trail will be reducing it. So this is how you can decide it.
Okay, sir, we have one more question. I think Geetika ma'am can answer it. Which software is better for suspension simulation? Geetika ma'am?
I would say that depends upon your requirement. If you have extremely basic simulation to be done on the suspension, so you have softwares like Lotus, which is a freeware. But then if you want to have an entire quarter car model, Amit, sir, did you say anything?
No, go ahead.
Yeah, okay. So if you want to have an entire quarter car model imported in, or a half car model for that matter, imported and simulated, then you have ADAMS. That is in the industry most commonly used software. If Ajay could add in.
That's extremely exactly the same thing I would like to say. But in between, you have another thing called MATLAB. But if you are very strong in programming point of view, you can also have do some sort of simulation in the MATLAB platform.
You can have actually mathematical simulation models which are run.
Yeah, there are some sort of platform like Simscape and Simulink. So basically, you can actually simulate the Sprengma system in that as well.
Okay. So next question is, while designing suspension, what are factors need to consider which will affect steering system?
The questions to Geetika.
Okay.
Because it's more related to the four-wheeler.
Okay.
Okay, so affecting the steering system. So in general, I would say that it will basically your I I am not that I don't think I'm the right person to answer this question in the first place because I do not have in-depth knowledge about the suspension affecting the steering system in general.
Okay, I can get into here now. Like, see, when you're designing the suspension system, generally the steering system is far apart from the like suspension point of view. It's basically the layout and how the suspension is, the layout is been designed, or like your all the camper, caster, all these things, and you have very little things to do with the shock absorber. So if you ask a question towards the shock absorber, you have little things to do with the shock absorber, but you have a lot of things to do with the other mounting layouts and like you see the caster and camper. So it is more related to the person who is designing those vehicle systems.
Okay, there is one more question to Ajay sir. Why spring and damper are mounted separately in the recent car, and how these mountings are more effective over conventional type?
Spring and dampers. See, the mounting depends on many parameters such as the layout constraints and your space availability. Okay, so and also it defines the strength requirement of the your swing arm or the trailing arm, whatever you say. If the spring is mounted very close to the pivot point, you will have to design your trailing arm or the swing arm to be such a rigid structure. And when you defines because it's a structural part as well, the spring is also going to take care of your structural load. Okay, so there is a thing that whenever you have a layout constraints such as that, and your strength requirement or the FPA guys will be explaining you something like that, then you might have to look for different mounting on the damper and spring separately. It's a very broad explanation, so it's case to case it will differ.
There is one more question. How the life of a suspension is defined and how much it is?
Yeah, I can take that question. When you say life of the suspension, there are majorly we consider two types of life. One is the performance life and another is the structural life. And considering the structural life, we assume the suspension should withstand till the life of a chassis. Generally, it goes up to something around 2 lakhs kilometer. But when you talk about a performance of suspension, or the life of a performance, like suspension life in terms of performance, it is limited to some sort of the warranty period of the vehicle itself. Generally, it will be vary from 30,000 kilometer to 50,000 kilometer with respect to the vehicle segment. Yeah.
Okay, sir. I think that would be all for today. All other participants are requested. If they have any more question, they can contact us. We can forward their questions to our speakers. Okay. Now I would like to invite Professor Deepak Gopekar sir to give vote of thanks. Sir, over to you.
Thank you, Amit. I would like to thank all the participants who have joined us for this session on vehicle suspension system and design. I like to thank Gabriel India for their cooperation and their support for this webinar to DIMS. I thank Mr. Abhange sir, Rajendra Abhange sir, Senior Director and Chief Technology Officer Gabriel India for his encouragement, support and his feedback throughout this session. I would like to thank Assistant Manager Ajay K, who is R&D who is in 2 and 3 wheeler division R&D, as well as I would like to thank Ms. Geetika Jayaram, Senior Engineer, Four-Wheeler Division, Gabriel India, for sharing their expertise in the domain of two-wheeler, three-wheeler, and four-wheeler suspension systems. I am sure that participants are having a lot many questions, so we have been noted down the questions, and the questions will be soon forwarded to the speakers, and it will be get answered. I would like to thank Dr. Ulhas Shiurkar sir, Director DIMS, for encouraging us and providing the all necessary resources for arranging this particular webinar. I would like to thank Professor S.B. Kalyankar sir, Vice Principal DIMS, for extending his support for the successful completion of this webinar. I would like to thank HOD Mechanical Engineering Department, Professor P.G. Taur, sir, for his continuous encouragement, support, and timely uh, presentation of the facts. I would like to thank coordinator and my colleague for this event, Professor Amitpal Singh Punewale, for his uh, support and help. Last, I would like to thank IT support and staff and all my colleagues for the successful completion of this webinar. The participants are will be provided the feedback links on the Telegram group, as well as they will be mailed feedback links to their respective registered email IDs with us. So thank you very much. Have a nice evening. Stay safe. Stay healthy.